All right, how's it going, folks? Last couple days we've been chatting about weathering, right? The breakdown of sediments, physical and chemical means. And then, of course, we've been talking about the eroding of those sediments by rivers and glaciers. Today we're going to focus on what happens when they stop being eroded, right? It's called deposition, and the features they make as a result, and how they are deposited, okay? Here you can see we're going different sizes vertically. I don't know if you remember, it's called graded bedding, right? Small, medium, large, small, medium, large, small, medium, large. And that's kind of a seasonal deposition that varies with rivers. Remember, rivers' speed varies throughout the year. So the size they can erode will vary. And they get deposited in that pattern right there. They call that graded bedding. Okay? All right, so here we go. Which particles will settle first? Which ones will be last? Take a look. You got round versus flat. Which one do you think will settle first or last? Place your bets, and boom! Here we go. Oh my goodness, look at that. Watch one more time. Who makes to the bottom first? Clearly the rounder sediments, right? They have less resistance in air or water. It's usually water in this case. And the flatter particles hit more resistance, so they settle slower. Okay? And there it is. The characteristics that affect how quickly something will deposit, you have their size, their shape, and of course their density, right? Denser things will certainly settle faster as well, but you can't see denser on the screen. Okay? Read this through. There's your official explanation of deposition there. All right, and there's your official definition. Sediments are dropped from an erosional system as the velocity decreases. Remember, as rivers go faster, they can carry bigger things. Well, as they go slower, they can't carry, as much sediment anymore. And this is how it goes. You break it down to weathering. It gets transported via erosion, and eventually it gets dumped, and we call that deposition. Okay? How does the particle size affect deposition? Well, obviously, the bigger things get to the bottom first, right? Larger particles will settle first. And, of course, cobbles and pebbles are your bigger ones. And the smaller ones will take more time. Clay, remember, that orange substance in the tube seems to take forever to settle. It's so small, and it's also very flat. Okay? All right. Here's this graph, size versus time. See if you can figure that one out. If the particle gets bigger, should it take more or less time to settle? Well, hopefully you said it would take less time, right? Bigger things settle faster. How about this one, size versus rate? Right? Remember, rate and time are kind of opposite effects there. So as the particle gets bigger, it should settle at a quicker rate, right? And it should look something like that. Okay. How does the shape affect deposition? Well, the rounder it is, the faster it'll get to the bottom. You saw that in the race at the beginning. The flatter it is, the slower it will settle. So that's where you end up getting, again, vertical sorting, and you can see that right there. All right, here we go. Flat to round on the bottom versus time on the y-axis. The rounder something gets, it should take more or less time to settle. Obviously less, right? The rounder it is, the quicker it settles. And now we juxtapose that with that rate scenario again. So as it gets rounder, it should settle at a quicker rate, right? And those are going to be opposites. All right, make sure you get that in your notes. All right, and then we have density, right? The last of the three. And of course, the denser it is, you can see these numbers here represent densities, grams per milliliter. The denser it is, the faster it got to the bottom. I know this looks smaller, but don't worry about size in this case, right? It's just density. So sure, the denser thing makes it to the bottom first, and the less dense, like silt and clay, will take longer to settle. All right, and one more time with the graphs. If your density increases, what happens to the time it takes to deposit? Well, the denser it is, the less time it takes, right? So juxtapose it with rate. If density increases, it should settle at a faster rate. So hopefully you went the other way on that one, right? A direct relationship. All right. Hope that kind of makes sense to you there. All right, let's keep rolling. Describe the relationship between rate and time. At this point, you should be experts on rate and time. They were kind of opposite of each other, but when you put the two together, if you do something at a quicker rate, then you did it in less time. So if your rate increases, then the time it took to do it, of course, decreases. All right, make sure you really go through that one, understand that. A lot of students mix that one up. But if you do something at a faster rate, you did it in less time. Okay, so here we go. We got a bunch of particles here. You guys got to figure out who gets to the bottom first. So arrange the sediments in order in which they would settle if it was in a calm lake. Right, so we're not moving anymore. The river has taken these particles and now we're depositing it in a calm lake. How would they sort in this little bucket here? And then, of course, there's a couple of Regents questions that follow. All right, I'll meet you back in a minute.